Hi, it's Mr. Van Scoy. We're going to continue our discussion about the Big Bang and more. Today we're going to talk about a moving universe. Today, when you're done with this lesson, you should be able to explain what happens to energy waves, be that light energy waves or sound energy waves. You should be able to explain what happens to those waves as they move, and you should be able to describe the evidence for a moving universe. We're going to start our discussion with the Doppler effect. A siren on an emergency vehicle changes its sound as it passes you. It shifts from a higher to a lower pitch as the vehicle moves towards you, and the sound waves are pushed together. So those sound waves, as it approaches you, are going to get closer and closer and closer together, making a higher pitch. As the vehicle moves past you, the waves are spread farther apart. A similar principle applies to light waves, what's called a red shift and a blue shift. So we're going to talk about shifting colors. Kind of keep in mind that Doppler effect, which is about sound waves, but keep that same kind of principle in mind as we talk about these shifting colors. Remember that each color has a different energy wavelength. You can see in the diagram here that on the shorter end we've got colors like blue and violet. So those are going to be your shorter waves. And then your longer energy waves are going to be the red. So, there's a bunch of other energy waves too, like microwaves, gamma rays. But for our discussion, we're just going to focus on the visible light, those colors. Again, remember that each color has its own wavelength. Okay. Blues, reds. If you were to look at a star's light through a prism, you would see a spectrum, or a range of colors through the rainbow. Again, remember that each color is the result of different energy wavelengths. If you change the wavelength, you change the color. The spectrum also has some dark bands, where specific elements in the star absorb certain light energies, certain light wavelengths. For example, in the image you can see that the element hydrogen absorbs some of the red colors. The element sodium absorbs orangish yellow colors. And the element magnesium absorbs some greenish blue colors. You don't need to understand or know all of the science of why that is true for our discussion, but just keep in mind that each element has a unique kind of color fingerprint of absorption. So different elements like hydrogen, sodium, and magnesium would result in a different color band and absorption band. That's, for our discussion, that's all you really need to know. If a source of light were moving, we would predict a color shift. Again, kind of thinking about that Doppler effect. Moving toward us would result in shorter wavelengths. Moving away from us would result in longer wavelengths. Remember that blue light waves are shorter, red waves are longer. So if it were moving towards us, we call that a blue shift. because the light would appear more blue. And if it were moving away from us, the wavelengths would get longer, kind of getting stretched out. So we would call that a redshift. While studying the spectrum of light from distant galaxies, astronomers noticed something very strange. The dark lines in the spectrum were in the patterns that they expected, these ones on top, but they were shifted toward the red end of the spectrum. So same pattern, but it's shifted. This shift of absorption bands toward the red end is what is known as red shift. Red shift then suggests that the galaxies are moving away from each other as the space between them expands, almost like a cosmic explosion. Something else that is interesting is that not only is the universe expanding, but it's also accelerating more as objects get farther apart. So there's definitely something going on there. Scientists have some ideas, but they don't have all the answers as to that acceleration. If we have time, we'll dig into more details about the acceleration of the expanding universe. All right, so after today's lesson, you should be able to explain what happens to the energy waves as they move. Energy waves moving towards each other are shorter. As they move away, they get longer. And you should also be able to describe the evidence for a moving universe, the redshift of the galaxies and the absorption bands as they move apart. If you have questions, as always, please ask.